Alright, let's do a linear programming problem. First thing is to define your variables. That's super important. So I always look at the very end. It says, what is the maximum score? It says, how many of each type of problem must you answer to maximize your score? How many of each type of problem? So I'm going to name my variables. X is now I'm going to go back and look at what they're telling me. You are about to take a test that contains computation problems and word problems. So X is the number of computation problems that you have to answer. They're assuming that you answer them correctly. It's a pretty strong assumption there. And Y is the number of word problems. It's important that you be more, don't just write computation problems and word problems, write your units so that you know what it is you're looking for, because that's going to help you when you do this next step, which is to find the constraints. Constraints means what are the limitations on these variables that you have. So what's the limitations on the number of computation and the number of word problems? So it says, let's go back and now let's find that information. It says that you are about to take a test that contains computation problems worth 6 points and word problems worth 10 points. You can do a computation problem in 2 minutes and a word problem in 4 minutes. You have 40 minutes to take the test. So I'm going to have a minutes constraint. My minutes constraint is 40 is bigger than or equal to, meaning 40 is bigger than, the max minutes I have is 40. And how many minutes does it take me to do each computation problem, X? It takes 2 minutes. So 2X. And how many minutes does it take to do a word problem? 4Y. 4 minutes. So 2X times 4Y. This is the total number of minutes that it takes me to do my problems, and that has to be less than or equal to 40. So that's my time problem, or my minutes problem. Then there's another constraint here. I'll change the color because we're going to need a different color anyway in the graph. And that's going to be this one. It says you have 40 minutes to take the test, and you may answer no more than 20 problems. Let's see. I'm sorry, no, that's not the 40 minutes. You may answer no more than 12 problems. So 12 is the maximum number of problems I can answer. So there's my next constraint. The number of problems I answer constraint is the green one. And what did it say I have to do? I can answer no more than 12. So how does that relate to X and Y? X is the number of computation problems you can answer. Y is the number of word problems you can answer. So what do I do with X and Y? I add them together. X plus Y is the total number of problems I would have answered. And that has to be less than or equal to 12. Alright, the next part is I graph this. And here, let me show you the best way to graph. By far the best way to graph when you're given equations in standard form or general form, depending on which book you've got, is to find the intercepts. The intercepts are going to be, for the green line, the intercepts are going to be 0, comma, when I plug in 0 for X, I have to plug in 12 for Y. And when I plug in 0 for Y, the X would have to equal 12. So 12, 0, and 0, 12 are my two intercepts. 2 points determine a line. It's a solid line, not dotted because of the equals part there. And so when I graph my line, let's go 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's a bummer. Let's go by twos. 2, 4, 6, 8, 10, 12. There's 12, 0, and 2, 4, 6, 8, 10, 12. There's 12, 0. And then use a straight edge to graph it, or use a nice line if you've got that. You'll want to try to graph it as accurately as possible. It helps you check your answer. There's the green line. Let's do the red line now. Same deal. I'm going to use the intercepts. If I plug in 0 for the red line, if I plug in 0 for X, think about this being gone. What's Y equal? 40 divided by 4 is 10. And if I plug in, so 0, 10, and if I plug in 0 for Y, get rid of that, the Y term, then X would be 40 divided by 2, which is 20. So 0, 10, which is up here, 0, 10, and 20, 0, which is 12, 13, 14, 15. I'm sorry, 12, 14, 16, 18, 20. Did I do that right? Let's hope I did. So let's graph that line now. And again, try to graph it as accurately as possible, because this number right here is what you're going to need to find in a little bit. I'm going to turn that into it. That point right there, I'm going to have to find that point, because that point, that's where the two constraints intersect. Also notice, by the way, that this is, we're not done graphing this yet, but it has to be in the first quadrant, because you can't really have a negative number of computation problems. So you're only really concerned with this first quadrant, quadrant 1 up here. You don't have to worry about anything below it. And we also have to graph. We have to shade now. If I plug in 0, 0 for the green line, is that a true inequality? Is 0 plus 0 less than or equal to 12? Yes, it is. So it's shaded down. And if you do that for the red one, you'll see that that's shaded down also. So here's your intersection right there, which means this point right here, let's label those points. 12, 0, this point right here, 0, 10, and this point right here, which we have to find now. Let's find that right now. I find that point by solving this system of equations. 2x plus 4y equals 40, and x plus y equals 12. By the way, I could have divided 2 by everything up here, and that would have been a lot easier. If I divide everything by 2, I would get 1x plus 2y equals 20. And that's a much easier system to solve, because all I have to do is subtract this entire thing and multiply it by -1 and add straight down. The x's are gone. I get 1y equals 8. So if y equals 8, what does x equal? Plug it into either one of these. X equals 4. So 4, 8. Let's see if that looks about right. 4, 8. Yeah, that looks pretty good. 4, 8. Because I drew my graph pretty accurately. All right. So that's finding your graph. That's your graph. And now we're gonna, the objective function. We have to come up with an equation for the objective function, and it's relating to the number of computation problems and word problems. And look what it says here. You're about to take a test. The computation problems are worth 6 points. So 6 times x is the number of points you're going to get for the computation problems, plus 4, is it 4 points? Plus, 10 times y is the number of, 10 is the number of points you get for every correct word problem. So 10 times y is the number of points you get for your word problems. And that is equal to my z. We usually call it z, your objective function. Sometimes you call it p for profit, if it's a profit type, but we'll just write z. So now what we're going to do is we're going to figure out which one of these 3 points, which one of my x, y points on the boundaries or on the edges of my feasible region is what this is called. These points are called critical values a lot of times, or critical points. Which one of those 3 points gives me the biggest z value? So I'm making a t-chart, and my points are 0, 10, 12, 0, and I'm running out of space, so let me add one more above it here, and 4, 8. So why am I doing this, you ask? Because I have to figure out which one of these points gives me a maximum z value, or a maximum total number of points on my test. So let's plug these in. Plug in 4 for x, 8 for y. What's 4 times 6? 24. 8 times 10, 80. 24 plus 80 is 108. So I get a total of 108 points if I did 4 computation problems and 8 word problems. 0, plug in 0 for x, I get 0 plus 10 times 10, which is 100. I get 100 points if I answered 0 computation problems right and 10 word problems right. And I would get 12 times 6, which is 72. I would only get 72 points if I answered only 12 computation problems. So the answer that they're looking for is 4, 8, 108. So let's go look at what the question asked and answer it correctly. It says how many of each type of problem must you answer to maximize your score, and what is the maximum score? So you say answer 4 computation problems and 6 word problems for 108 points. And that's your answer.